Next, let's take a look at a script that uses trap, but in this case it traps a whole bunch of signals and does not execute any command for whenever signals are received. And then what it does is sort of implement password protection of a script. So it's very simple. The idea is you set up your secret password right in the script. It's all visible here in this script. It's the secret password in this case is just UWRF. Then it says protected area. You have to enter a code and you read in whatever the user types in, compare it with the secret password, which is UWRF. If it's not the secret password, then you ask the user to try it again. Enter some other password, or enter a password, and you check it again. You read it in and then compare it with our secret password. And if the user does not know the password, you just stay stuck in this loop. And if the user does know the password, you really don't do much in this script. All you do is print out a message. Okay, so let's take a look at how that works. So I believe it is select 1203. Okay, so there it is. Here's the all critical trap command. This is what prevents signals from interrupting this code. So what is that for? Well, let's say you ran this like 12.03.sh, and let's say this is a protected area. You can only proceed if you know the password. If you don't know the password, you can't execute any commands. You're just stuck here in this sort of login mode. So you might say, well, I'll start at the beginning and try that. I don't know how many letters there are, but let's try all B's and so on. Pretty soon you get tired of that and you just type in other stuff. You're trying to get past this password. Then you say, well, I don't need to deal with this. I can hit Control-C, but here's where the trap command blocks you from going any further. So you hit Control-C. Oops, can't get any. But now I crashed the program. So yeah, there is a problem with this. It's not perfect. You hit Control-C and then you hit Enter, and it turns out you can get past it. We'll have to tighten up our defenses in that program. But let's just try that again. So yeah, so it's not perfect, but it can block you from Control-C'ing through this. Okay, so let's say you don't know the password, and then you pay up and you find out what the password is, and you say, oh, okay, I know the password. It's UWRF, and you're in. Okay, so as you saw, it's not perfect. Let's just cat it. Like 12.03.sh. It's this line that prevents you from Control-C'ing it. So, however, 1, 2, 3, 4, 5, 6, 7, 8. Somewhere in here there is a. It might be here. We should, if we were to make this a little bit more bulletproof, we should probably protect some things over here to not have the script crash. Okay, so once again, the main idea was just to show you how the trap command works so you can prevent people from Control-C'ing past something. You can make it even more sort of bulletproof by removing or turning off screen echo. And I believe this is also here as script 4. So all you do is turn off the echo, and then once you do that, if you were to run this program, just lec12-04, when you type in stuff, you can't see what you're typing in. Sometimes this is a little bit more safe because the user doesn't know what they're typing in, so they can't just try to brute force their way through many different passwords. Or they can, but it's a little harder. So I know I'm going to type in UWRF, enter, and I got it. Okay. So these are all little things about the script that you can use in your own scripts. So try these out. There's a whole bunch of different files. Try running this and sending it a kill command. Let's just try that real quick. So let's say this is part of some bigger script. Oops. Oh, here's a nice thing to show you. Right now, there is no echo. And you have to use the STTY. Oops, I can't see what I'm typing. STTY echo. And now my echo is back. So that's another thing to keep in mind. If you ever find out that nothing you type shows up on the screen, the thing you want to type in is STTY echo. Try that. That might work, and that's what worked this time. Now typing that turned on the screen echo. So maybe just one more word about that. You might think that when you type in stuff like this, just letters, numbers, things like that, it goes straight from the keyboard to your terminal program or your shell, your bash shell. Turns out no, that's not the case. What happens is, and these last few examples basically show you that when you type in stuff, it goes to the bash shell, and the bash shell actually prints out everything you type back out to the command prompt. And that's why you see every single command. When you type in ls, those things are coming in through standard in, that is the keyboard, into the program. If you want, you can turn off echo and nothing will ever show up. Your ls, things that you type in at the keyboard, are not always echoed out to the screen. So once again, when you type in stuff, anything, whatever it is, you can turn off that echo. That is, normally the normal mode is for everything that's typed in to be echoed back out to the command prompt. And you can turn that off like you just saw. And what happens then is, and everything you type in is received. So it is actually going into the program. It's just that you're not seeing it. So, okay, so that's another good lesson from this set of scripts. So STTY minus echo turns off that screen echo. Okay. Next up, we will look at this exec command. So you might want to review that little part of, I believe it was lecture 10, about fork, exec, wait, and exit, those kinds of things. This is slightly different in that this is a command, and at first glance it looks like this is a pretty useless command, because if you were to type in something like this, what this does is it says, okay, there's bash running, so bash is the program that asks you to type in stuff. You type in exec date. This command, what it does is it wipes out bash, and in place of bash it runs whatever command this is. But the thing is, as soon as you wipe out bash, your terminal disappears, and so you never see the output of this. So let's try that. And once again, at first glance this looks like a very useless command, but it turns out what you use exec for is to write to different files inside a script. Yeah, it sounds kind of strange. So I know for sure that when I run exec with another command, it will wipe out my shell. So what I'm going to do is I am going to start up another shell. I think I have one, but just in case, I'm going to start up another one. Okay, so here is a second shell. I think I have 3 shells now. And you can do this too. You can have any number of shells. So I'm going to clear this. So I have one over here, another one over here. Let me change the prompt. ps1 equals /t space /w. You can't see everything I'm typing in just because I moved it too far. Okay. So now I got a smaller prompt. That's better. Okay, so here's what happens. You type in exec date, and the whole thing just disappears. Okay, that's normal. That's what it's supposed to do. So you can do anything you want, exec anything, and what that does is basically kill your shell. Because exec is used to execute a new command in place of what's currently executing. So in place of bash, it executes date. It's just that you will never get to see the output of date because the bash shell is gone. So another way to check this would be to actually run it inside another shell. So let's just take a quick look before we do that at what exec does. So here's your TTY program. So remember that if you say ps, remember that you're executing in this TTY, PTS /3. PSAF will give you more, a bigger list of all the processes that you are running. And there's PTS4, PTS3, there's all these TTYs that are in the background. Remember that you get to those by hitting Control-Alt-F1, Control-Alt-F2, and so on, and Control-Alt-F7, I believe, to get back into the graphical user interface. So all of that is still running as usual. Let's take a look at the notes. Okay, so all of that is still running, and bash runs in one of those after you log in. And then if you are in bash and you execute this command, exec date, what happens is bash is replaced. Just like if you were logging in remotely, you would have a login program that's replaced by bash. In this case, once you have bash running and you hit this command, exec date, what exec does is replace bash, and in place of bash, you run the date command. Now it turns out we don't ever see the output because when you remove bash, that whole terminal program just disappears. Okay, so what happens is in the end you get this TTY process that's still running, but there's no way for it to run bash right now. Or if you're logging in remotely, you don't have min get TTY or some other TTY program. What you have is the SSH daemon on the server side is running, but there's no way for it to receive commands because bash has been removed by this exec command. Okay, here's another way to run it. You can start up a new shell under bash, and then when you start up a new shell, it does not replace this bash, it just runs sort of inside bash. So let's try that. Let's try tcsh, oops, which we don't have. So you run something else like sh. Okay, so we know that we're in a different shell now. And now we can hit exec date. And here what happened, notice what happened was it killed the sh shell. And so since bash is still running, we went back into bash. So make sure you understand that. It's a fine point, but it's a very important one. Make sure that you understand why, in this case, the terminal did not just disappear. We started a new shell. We essentially killed it by saying exec date, and so we returned back to the shell we had before. And that's what's described here. So in bash, we start a new shell, we hit exec date, kills that new shell, and then we go back to bash. So this is the picture you want to keep in mind for this scenario where we start up a new shell and then run exec.